Hello everyone, it's September 24th. Well, we have to do a bit late today because I spent the entire day, actually I spent the entire week this week to publishing some app to the App Store and the Play Store. Now, the publishing part, I thought it would only take like maybe a day or two, but eventually it took way longer than that because the obstacle is always with the screenshots. Right? Being me, I like to do it automatically, but to set the whole thing up automatically, it takes a lot of trial and error. But mostly, it's just my machine sucks. Right? My machine is slow, so every time if I want to test a new setup for the screenshot, I have to wait for like 15 minutes. 15 minutes. Like I change some stuff, I have to wait 15 minutes for it to take effect because it takes that long to build an app. So overall, it's frustrating, but finally we're seeing the light at the end of the tunnel. But just to take a break from it, I'm gonna do it. Let's see what we have today. Possibly a tough question, but what we have now is a Fibonacci number, the nth Fibonacci number. Okay. So in 3 is the sum of 3. Return the value of Tn. Alright, so that is not a hard question. I mean, you just initialize these 3 and then just iterate through it. Right? Yeah. So I remember doing this problem for dynamic programming. It's like one of the first introduction to dynamic programming, because this one you need to cache, right? If you do it recursively, which I mean, it is easy to do it recursively, but I don't see the necessity to do it. Like the bottom-up solution is very intuitive, right? The bottom-up solution is intuitive, so you don't have to do a top-down recursion. But it is good practice for recursion, a good practice for, good practice for dynamic programming too, caching, right? Caching. So can we? I don't know. I would like to, because we only have 37, so we can just set up 37. Or otherwise, we have to do if and else at the beginning. If it's 0, if n is 0, right? Turn. I don't like it because we only go to 37, so we just. Let's think about a more generic solution. Okay, that's fine. You convinced me. If n is smaller or equal to 2, right, and then we return 1. All right, now we have t0, right, then t1, and then t2 equals 0, 1, and 1. Then for actually, I don't care this in range n minus 3, right? Then t equals t0 plus t1 plus t2, right? And after that, we're going to do t0, t1, t2 equals, well, t0 will be t1, t1 will be t2, and t2 will be t, right? And we're going to return t. Yep, I think this shall be it. 4 returns 4. 25 returns 1, 3, 8, 9, 5, 3, 7. Okay. And this is a unless there is some trick that I don't know. Oh, and look at that. Which part went wrong? Oh, 0, 1, 2. So it should be -2. It's not -3. Yeah, because 3. Yeah. There we go. Now we're talking. It should be -2, not -3. Yeah, let's just go for it. So, wow, what's a softball? Oh, this must be this is an easy question. Unbelievable. They did an easy question on Friday. Well, I don't have time today, otherwise I definitely would do another one. Just follow the description of Fibonacci number. ON. What's the runtime? 28 milliseconds. 83. Time ranking. All right. Wow, an easy question on Friday. What does that mean? That means tomorrow is going to be very hard. I think that's what it means, right? Unless it's labeled, I don't think it's labeled medium. Oh, come on. My laptop is slow as hell. Yep, it's an easy question. So, easy on Friday. Yep, I'm a little bit worried. Preparing for tomorrow. So we have what, like 3 easy this week already? 3 easy and 2 medium. DP and matrix power. What's matrix power? Oh, matrix power. I now realize. ABC. Oh wow, we can do it. 1, 0, 0. Oh, I see what you're doing here. C is so A will equal to B, B will equal to C, C will equal to A plus B plus C. So an initialized C will be 0. That's actually, I think it's -1. That's a -2 position, right? And then add them together, 1, right? And then A will be in the 0, 0, 1, and add them together is another 1. Oh wow, that's pretty smart to start with. Yeah, I have -2, -1. Good. Faster ON solution for big N. Fact matrix power. You can write it as the equation of sumamente matrix occurrence. The matrix power. And 3 is the size of matrix. The big M. So this is matrix power. And then simply do power. and the top row, first one. Given module. Oh, it's modular. Modular. While n larger than 0. If it's an even number, then we're going to multiply by m again, right? And then we're going to do dot m and m. Now it's odd. If it's odd, we accumulate the result, right? Otherwise, we're just going to multiply by themselves. So that's all log n here. How do we handle this? Multiplication. Let me see. I think I remember this. So it's what's 1, 1, 1, 1, 0, 0, and 0, 1, 0, right? So if I multiply myself, what do we get? So we have added together as the first one, and then this and this. What is that? That's the what is that? First row, second column, 1, 0, 1. So we have 1 plus this plus this, and this by itself, right? So 1, this is going to be 2. Second row, we just get the first one, and then also the first one, all the first one, and this one is the second one, right? Second one times this is also 1, 1, 1. So this is the second one. That's the first one. So 1, 1, 0, 1, 1, 0, first one. And then it times itself again. This times this. This plus this. I don't understand. Anyway, so 1, 1, 1, right? Oh, hold on. So 1, 1, 1 times this. We do m times result. So it's 1, 1, 1 times. So the first column is the values, right? And then we aggregate and we put that in the first spot. Okay, and then we have the second will be this times this, which will obtain this value. And third will obtain this value. Okay, now I kind of see how it is. Now what about the remaining? I have to worry about the remaining. Oh, we don't have to worry about the remaining. So we only worry the first column. The first column is the ABC, and then we compute the sum by 1, 1, 1. Right, 1, 1, 1 compute the sum of the first column. That will be the next value. And the second row is 1, 0, 0, which means we pick the previous matrix, the top left corner. That will be the second value. And then the third value of the previous matrix is the second row. I see. Oh, wow. This is which means if it's Fibonacci, it's like 2. So we're going to have a matrix of first row be 1, 1, right? And the second row, what we want to do is to get the first value, so 1, 1, and 1, 0, right? So 1, 1, and 1, 0, that will be the Fibonacci number. Nice. Oh, great. But you have to write the power, right? You have to write the power for, but I think this is what, considering, oh, the size of the matrix, like this, it does take into consideration size of matrix. So if n is huge, and the size of the matrix is not huge, then the overall can be smaller than. Oh, I see. Okay. Gotcha. But still, right? Still, I don't know. I mean, I might be able to figure out, but it's always easier to do it this way. Now this is easier than this. This is more intuitive, right? It's more intuitive, and actually, yeah, you don't have to do it. I can just put this one here. Like I don't have to have an intermediate. Just go direct like this. T is not defined. Oh, so we return. Well, after the first round, we always return T2. Yeah? And this is a good trick. 1, 0, 0. Basically just keep shifting. I'll just keep it like this. Intuitive. Alright, I am done and I'll see you guys tomorrow. Adios.